Hi, my name is Rick Bacon. I'm Chief Executive of Aqua Metrology Systems, and this is a brief overview of online real-time monitoring of trace metals in drinking and wastewater systems. This brief presentation explains how this technology is being rapidly embraced by the water industry because of the immense value it is bringing to it. I'm also going to address an issue of great importance, that of data quality. And I'll close with an introduction to a couple of significant new innovations in the water industry made possible by online trace metal monitoring. Traditionally, treatment system vendors have sold their technology and walked away, happy to lock in recurring revenues from consumables, but leaving behind any guarantees for system performance. That becomes the problem of the utility. Real-time trace metal monitoring represents a paradigm shift in that. As this slide demonstrates, real-time control of influent and effluent can now ensure the treatment system is operating as required or alarm as soon as a non-conformity occurs and before consumers' health is put at risk. Uniquely, AMS monitors its analyzers in real time to ensure data quality and availability, which I will now discuss. The value of real-time monitoring in a mission-critical role depends very heavily on these parameters, which relate to the data the analyzers generate. The first parameters, limit of detection, accuracy and precision, are critical, and the performance of online analyzers needs to be evaluated under field conditions, not in a lab with distilled water that has been spiked with a contaminant of concern. This is the basis on which instrumentation manufacturers advertise their products, but frequently it is no indication of their performance under field conditions. Data availability refers to uptime, often measured in terms of mean time to failure or mean time to repair. Accuracy and precision and price are irrelevant if the analyzer fails frequently and takes ages to be repaired. Fit for purpose addresses several concepts. Frequency matters in terms of the online analytical process cycle. And if that takes 2 hours between measurements, it is of no value if contaminant levels need to be analyzed every 10 minutes. Representativeness addresses a tendency by the water industry to use proxy indicators. But we all know that water is a complex chemical, and measuring the presence of a proxy indicator X for the presence of contaminant Y, because that's a cheap and easy thing to do, risks yielding false positives or false negatives. And this is clearly a false economy when Y can be measured directly, accurately and precisely by online instrumentation. Predictive addresses the fact that some contaminant levels, such as lead in domestic water supplies and in schools, cannot be analysed easily and frequently. Online real-time data that can now predict consumers' and school children's exposure to lead contamination before they drink that contaminated water is now available and being deployed. And finally, verified. Is the analyzer equipped to identify false positives and false negatives? In other words, does the analyzer self-calibrate and self-validate? Because if it doesn't, you're going to need someone to do that, someone who's probably trained. So then you might as well use a lab for your analysis and not an online instrument. There's not time to go into all the applications for online real-time water quality data that go beyond the obvious: process control and risk management. Suffice to say, online analyzers are being used by utilities and engineers to address a wide range of challenges, from characterizing contaminant levels across a water treatment system before designing an upgrade or a new system, to validating new treatment technologies. Water blending is also a major application for real-time data, where utilities are able to now blend water from contaminated wells with water from higher quality sources to still produce a blend that is safe to consume. I've included a couple of case studies. This one is from Cal American, who's been using for several years online instrumentation to control the performance of their Chrome 6 removal system and ensure that consumers receive safe drinking water 24/7. And El Paso has been a client of Aqua Metrology systems for several years and are using real-time monitoring to control arsenic levels in water that's been treated to remove that arsenic and make sure that it's safe again for consumers. I now want to turn to two main innovations. The first made possible by total system control that real-time monitoring provides. Treatment system vendors are now in a position to guarantee performance and so can offer long-term design, build, operate contracts under which they are paid per gallon of water treated. This is an attractive public-private partnership and provides a source of much-needed private funding to the utility sector, whilst ensuring that the vendor's technology performs as it should. Current lead contamination detection methods for homes and schools are utterly inadequate for protecting consumers. The latest innovation in online lead monitoring is capable of immediately detecting increases in the risk of lead contamination as a result of changes in water quality and warning consumers and utilities so that both can take remedial action before consumers are exposed to lead poisoning. This concludes this overview of the applications of real-time trace metal monitoring and the considerable benefits it's bringing to the global water industry. Please don't hesitate to contact me for more information. Many thanks.